Welcome back to this class. So here today we'll be discussing enterprise integration pattern for multi-agent system, which is this chapter 9 of the contents of the book Multi-Agent Orchestration Pattern for Enterprise Scale System. So we've gone this far from chapter 1 to chapter 9, looking at the guidelines, the design principles and patterns as defined in the book. So the link to the book is in the below information. Please kindly get your copy on Amazon. So I've also put the link to my website for consultation, and then if you want us to build one for you, or on our website, all our services are there. We build and design data engineering platform and pipelines. We do advanced analytics and data science. We do data ops and MLOps. We also do managed services. If you want, after design and deployment, you want us to manage this for you. And then we also build agentic AI system and LLM and generative AI and machine learning. And then, of course, we are grounded with a cloud implementation like Azure, AWS in particular, and also GCP if that is the platform that you use. So this is everything we work on is with data. So we work with data from extraction to transformation, loading. We build RAG databases, vector databases, embedding and chunking, and then retrieval. And then we build fine-tune model if that is what you want. So visit Rema AI Solutions.tech and contact us, send us your information and contact, and then we'll schedule a call with you. And then we deliver the best architecture using first principle, and all our work are rooted in applied mathematics background from the table of the team lead, which is a mathematician, MSc and BSc mathematics in particular. So thank you. So now let's come back to business we have today, which is chapter 9 of the multi-agent orchestration pattern, which I call MAS as a tag. So in chapter 9, we have enterprise integration. How do you integrate multi-agent system with enterprise system, with legacy SAP application, ERP, and other legacy system? So integration is another very, very, very brown field of reality that you must pay attention to when you are building multi-agent system, because agents are not here to replace this legacy application which you have been implementing for like 20 years, 30 years, and so on. No, they come to enhance the usage of this application. They come to make this application accessible so that you can get your information directly and as soon as possible, urgently, in real time from this application, and then thereby also increase reducing the difficulty of business process and obtaining business value. So this is what agents are here for. They are here to enhance your legacy application, not replace them entirely. So in chapter 9 we have a important discussion. Okay, as you can see here. So first of all, we have a word introduction to legacy system and the pattern. So legacy system extend with agent intelligence. As I told you, agents extend the capability of legacy system. They do not replace them. Okay. And when you are connecting to legacy system, we have what we call the anti-corruption layer, which allow you to get accurate data from the system by passing whatever is coming from the system through anti-corruption layer, okay, to ensure that we are not generating corrupt information from the system into the agent. Then convert agent output into exactly the format the legacy system expect. So if you are feeding or writing data back into the legacy system, you must also make sure you convert whatever information you are generating from the agentic system into the format that the legacy system like SAP application can accept. So enterprise agents must integrate with real business system, and common system include SAP for application for manufacturing, oil and gas production, and so on and so forth. We have the ServiceNow for IT management service. We have the CLM. We have the ESB. We have the PBM. We have databases, relational databases or repositories like file, and we have external application APIs. So anti-corruption layer translates messy legacy data into clean agent-friendly formats. So when you are connecting to legacy system, always make sure you implement the data engineering pipeline, extract and transform the data, and make sure data are well transformed into what agent can implement and use. So why modern agent intelligence must coexist with decades of old system and mission critical infrastructure. You have the integration layer. So this integration layer is very, very important, and that is why, as I told you, agents will not replace job. Agent will only create new job. Now here, agentic engineers may not be able to integrate the agent they have built into the system. So you have another important role, which we call integration engineers. So it is integration engineers that will now integrate the agent that the agentic engineers have built into the legacy system, because they have the expertise and the understanding. So you can see that another role is being created in the process here. So enterprise agent system do not operate in a greenfield environment. They must integrate with legacy system, as we have said. The legacy system are trusted assets with institutional knowledge in their configuration. So integrations should extend them with agent intelligence without totally replacing them. So they contain all the institutional knowledge, historical data from the inception of the enterprise up to date. So if you are replacing them, it's like wiping out all your history, all the history of your enterprise, which is not good. But you integrate them with intelligence agents to make the application or the system more intelligent and more useful. So that is what multi-agent systems are here for, not to replace the application, but to enhance the capability of the application. All right, so we have the anti-corruption layer in practice. How do you implement anti-corruption layer? Okay, so we have said anti-corruption layer is extracting and transforming the information from the legacy application into a format that is consumable by the agent. So decoupling agent domain logic from the text of proprietary binary formats and flat files. In the system you have in SAP, for instance, SAP keep data using code like Mara, you have Mara table. In Mara table, you have column codes. So all those are codes that you must transform into what the agent can understand and implement, because you don't want to feed data from legacy system into your dashboard and you start seeing Mara. Okay, the executive may not understand what Mara is, which is a technical language for naming a particular historical table in SAP system. And then in a blob storage of files, for instance, you have flat files which contain a proprietary of information in binary format that you must be able to read and interpret so that the agent will understand and be able to use them in operation. So this is very, very important. It is very, very important that you pass the information coming from legacy system to anti-corruption layer by building a pipeline like data engineering pipeline. So legacy data format translate fixed width or XML data into an agent-ready format safety. So you have all these are design pattern that you must implement when you are designing anti-corruption layer for extracting information from legacy system. So design legacy data formats. That is, make sure you design the format that is coming from the legacy system, like XML file, like flat file, like coded data, design the format that is coming out from the system. And then after that, you design agent domain objects. So this is a typed human readable model that stays independent of legacy schema changes. So, or after designing the legacy data format, the next thing is to extract and transform it into agent domain objects, what the agent understand and that is also readable to human model that stay within the agentic system. So you have your data in that format, and after that you design bidirectional translation. So this keeps right back from breaking data rules like field width or null constraint to design right back, that is back and forth information. So the if you are writing back to the legacy system, it must be able to understand the information. And then if you are writing to another application, the application must be able to understand the information. So you have a bi-directional kind of communication between the agent and the application. That is, we implement what you have. This is, for example, let's assume you are extracting data from SAP system. You've transformed and load into a database, and then you want to use another agent to generate KPI and feed the data into your dashboard for visualization. So that is bi-directional. So you must be able to generate information from the visualization to the database and feed information from the database to the visualization dashboard. Data quality scoring. So adds a quality score and audit trail for mappings like SAP A to approved. So like I told you, SAP keep coded data like PP, like MM, like wherever layers, and you have the table like Mara, like uh PKK, like VP, VPBP, and so on and so forth. The way they name their table and their columns like that. So quality scoring, make sure data is well transformed and it is of high quality, and then transform all the coded or binary files or coded columns and tables into full form meaning of what they represent. And then we have centralizing control with agent aware. So centralizing control with agent aware. So manage cross-cutting concerns like authentication, rate limiting, and circuit breaking at scale. So when you are integrating, design for centralization with agent aware. So make sure you design for authentication. Agent must authenticate before they are authorized. So authentication and authorization to legacy system do not give direct permission. So also implement rate limiting so that when agents are pulling information from the legacy system, they don't crash the system down. Also implement circuit breaking and so on and so forth. So how do you design for this? So control every entry point. Control the entry point through authentication and authorization by preventing agent from managing its own retry logic or OAuth2 credential. Make sure you have central implementation policy designed for this to govern how agent access legacy information. So implement control entry points. Then after that, you design agent aware rate limiting, that is limit per backend, like sanction database, not per agent instance. So limit or rate limit per backend, not per agent instance. So when you are implementing rate limiting, focus on backend. Rate limiting is designed to protect the backend and the database, not the agent themselves. So design or rate limiting to protect your database and your backend or your legacy application. Also implement circuit breaking. So when this enable fail fast when a backend is unhealthy, saving expensive agent computation time. Your agent has they've pulled LLM token and they want to access the backend, and the backend is unhealthy. So the token that they have generated and pulled is generating cost, and the cost will just be wasted because the backend is not accessible. So implement circuit breaking. so that you will prevent wasting unnecessary cost when the backend is unhealthy or inaccessible to the agent. And then we also have intelligent retries. So exponential backoff with jitter to avoid the thundering head pattern. So implement intelligent retries. So this is where you design for retries. That is how many times should the agent retry a failed operation. So you can implement this by using exponential backoff with jitter, which enable retry operations in a controlled system. So this is how you control the entry point to legacy system application and API and databases. So we have section 9.3 where we discuss service mesh architecture. So service mesh architecture is when you implement mutual TLS and least privilege authorization policies for autonomous agent fleets. Agent fleets are multi-agent system as usual. They are swarm of agents, multiple agents like 21, 50, or you can even have 100, depending on what you are building. If you can manage it, of course, why not? So service mesh architecture is very, very important because it allows you to divide your agentic system into small architectures, manageable, and but that you can also govern and control, at the same time. So this is how you can implement that based on these design patterns. We have policy components, functionality in agent context. So peer authentication, you can implement an architecture for that where you enforce MTLS strict mode, rejecting any non-authenticated connection between services. So that's another mesh, a mesh that you can implement, peer authentication. Then authorization policy, by implementing least privilege, the compliance agent is only callable by the orchestrator, limiting blast radius. So when all agents is implementing authorization, asking for authorization, you have a blast radius, you have, we have a system downtime, no doubt. So agents authorization policy should be limited to the orchestrator if you are following our design pattern, multi-agent orchestrator pattern. So the orchestrator implements authorization policy and send information to other agents. So the other agents only receive information from the orchestrator. So meaning that we only allow the orchestrator to have access to the legacy application, and the compliance and audit through everything, it's designed to, or for the orchestrator to use to access the legacy system. And then we have another service mesh pattern, which is virtual service. So manages routing, timeout, and canary rollout for new agent version or prompt templates. So implement virtual service. Make sure you do a virtual simulation of agent before you deploy them into the system when you are building new one. So also manage routes, manage timeouts, and your rollout for new agent version. Implement agent versioning. When you are replacing old agent with new agent, make sure you implement versioning. Have version 1, version 2, etc. And then, of course, as we have said, fashion your prompts. Treat your prompt as codes. So I also have prompt template versioning, so which allow you to have, a performance and auditable system. Then destination rule, define connection pool and outlier detection to eject failing pod for the load balancing or pool. So make sure every agent have destination pool. So make sure they have connection pool. Every agent pool should have connection pool, and also detect outlier. So if agents are crossing boundaries or doing what they are not supposed to do, or collecting information that they are not supposed to collect, implement guardrail for this. And if when you're operating pools in your service mesh, make sure you load balance the pool. Okay, so make sure everything is load balanced so you have a reliable system. Then we have bridging the gap. So how do you bridge agents to ESB or other platforms like ERP, Oracle or ERP, IBM, MQ, SAP, ECC, or SAP S/4HANA database, and so forth and so forth. So participating in existing messaging backbones like IBM MQ, MuleSoft, Azure Service Bus. So you can bridge agents to ESB using Azure Service Bus, for instance, to receive and send messages. So, and then we have the design pattern here. The first one is enterprise agents, enterprise events. Agent react to enterprise events such as purchase order, approved in SAP or CLM contracts using Service Bus, not direct communication. Correlation ID. This bridge links ESB event to specific agent workflow instances, preserving bus added enrichment via Service Bus. And you have another design, outbound publication. So the outbound pattern publishes agent decision back to the ESB for procurement and supplier portal, for instance. And reuse and governance. This respects existing integration and lets the agent system inherit ESB reliability and governance. So these are all design patterns that you can use a tool like Service Bus for when you are designing or integrating system with legacy application. Then we have a data pipeline, which is what we discussed in section 5. So orchestrating multi-stage batch processing for thousands of records with robust recovery. So you have a multi-agent stage batch processing for thousands of records with robust recovery. And then how do you design this kind of pipeline? So you follow the design pattern for data engineering principle or design pattern. So extract and transform from the legacy system. So this pulls active vendor master data from ERP and enriches it with risk profile. And then we have parallel execution. This enables you to process a large amount of data set with high velocity, like vendors, 50,000 vendors in parallel, while respecting API rate limits. And then you have checkpoint, also designed for checkpointing recovery, so which saves progress every 500 records to avoid restarting after networking timeouts or network timeouts. And then you have another design pattern, which is dead letter entry or dead letter handling. So dead letter is not a refuse dump of data, as we have said. No, you should observe your dead letter. So isolate failed record in a queue for human review without blocking the pipeline. So all failed records should be isolated for human review. They should be observed and collected and reviewed by human, not just and do not let them block the pipeline. Do not just dump them. Make sure they are collected and reviewed by human, and do not design them to block the pipeline. So this is what we have for pipeline or collection, pipeline design pattern to integrate a legacy application with multi-agent system. So we have seen the design patterns now. We have seen surface integration using API gateway, integration using surface mesh architecture. We have looked at integration using Service Bus or Azure Service Bus if you are using Azure Cloud. We have looked at integration using a data pipeline. Can also integrate with legacy system through data pipeline. For example, I just implement this when I build a 6 multi-agent system for Procure IQ, which I call Procure IQ, which connect to SAP data platform to extract information, process and transform the information, and feed the dashboard with such information. So you can use this method also if you are building a data analytic platform that will connect to SAP application and connect and feed to your dashboard with your KPI already in place. Then we have external system connections. Another design is external or securing external connector for compliance and data. So handling protocols for sanctions list, legal citation database, and regulatory field. So these are the designs that you can implement in this pattern. So you can implement raw response hash. This raw response hash record the raw response hash for F. So how do you implement this? So let's read what we have here. Record a raw response hash for every API call to keep an immutable audit trail and prove the screening decision use exact data provider. So make sure every response from the legacy system are hashed. This allows you to keep record of what is coming out of the negative legacy system as well, okay, for accountability. Then we have citation tracking. So for legal agents, implement citation tracking to guard against hallucinated cases and verify that every cited document exists. So of course, we have said that the LLM, which is the brain of the multi-agent system, may hallucinate and generating wrong information into the agent. So make sure you implement citation tracking, okay, to make sure the agent is implementing information or documents that are cited in the system that exist in the legacy system already, are not generating, an information that is not in record. So to prevent against false output. Aggressive catching and cost tracking. So use aggressive catching and cost tracking, as these external services often charge per search or per document retrieved. So make sure you use aggressive catching. Always catch information from the agent. Make sure you track costs and use external services. So to of and monitor the use of external services, because they may charge per document retrieve as well. So these are the sign pattern for you to secure external connectors to the legacy application system. And then we have section 9.7, where we have workflow engine integration. So how do you integrate workflow engine to the system? So preserving existing investment in ServiceNow, SAP Workflow, and Camunda is very important. Remember, you are not using agent to disrupt or replace the system. You are only using agent to automate the system, okay, and make the system autonomous. So BPM engine, these are the design that you can implement. BPM engines. Organizations have invested heavily in BPM engines for approval and escalation. So integrate BPM engine for approval and escalation. Also design for legal review agents. You can implement this design pattern. A legal review agent add risk assessment to the human queue, supporting human agents. So you can use this design pattern for workflow engine, and then you can use external task worker. The pattern lets the agent platform pull AI agent task item, run logic, and return results. So external task worker improve workflow by implementing this, allow the agent to run logic and to return results using this design pattern, AI agent task. It's in the book. You can read more about the code and everything. So invisible to owners. So this keep the agent system invisible to process owners who keep using familiar tools. So the process owners that are, using the application or at the other end using the dashboard will not see the agent that is performing the task. So this way, invisible owners will design pattern will enable you to protect the agent from, people using the SAP application or people using the dashboard for reporting. And then finally, in section 9.8, we have cloud deployments. So for cloud deployment, we have on-prem, we have hybrid, we have private cloud, public cloud, and we have a validation planner. So this is very, very important. Another very important design that you can use. So align agent deployment tiers with data classification and jurisdictional requirements. Okay. So on-premise require for restricted data, such as national security contracts. So you can deploy on-premise if you want your data to stay in your, in your environment, in your office. You can use on-prem. You don't want your data to cross border. You don't want your data to be stored on the cloud. You want everything to be governed, on your system, in your office, or where your company is located. Then you can use on-premise integration, or you can deploy your agent system on premise. Then you can use private cloud. This is ideal for confidential data subjects subject to GDPR, HIPAA, or attorney-client privilege in legal system. Then you can also use public cloud, which is used for internal data like IT incident classification. So these are the data that are allowed to stay in public cloud like Azure, GCP, or private cloud are like virtual machine and institute that you can just deploy on your system. Then we have number 4, validation planner, which is a centralized registry that eject deployment spec above tiers, security, or rating. So also implement validation planner or to register to reject deployment spec above security tiers rating. So every deployment that does not meet security data or standard will be rejected by validation planner when you implement it. So this is all the design pattern that we have for enterprise integration. And of course, enterprise integration engineers are the ones that can even break this down further and explain it better. So we just implement it, but we have idea of it as well. So, and this is the what the architecture look like for enterprise integration pattern. So connecting agent platform to the enterprise system. And then we have the layers. So the first layer is where you have your legacy system, which are your core system. Legacy system, SAP, ERP, for instance, IT ServiceNow, ITSM management. And then you pass everything, as we have discussed, through anti-corruption layer, which is where the protocols, you have protocols translation, data transformation, canonical models, and before the agent will now connect to it. Remember, we said you should implement bi-directional architecture, okay, so that communication can be back and forth. So you have API gateway, which secure access and routing. You have surface mesh architecture, which allow traffic management and observability using rate limiting collateral metric. And then you have all this connected to your enterprise agentic platform, where you have your agents, your workflow, your tools, and your states, which is memory management and your orchestration layer. And then your agents are then connected again via events bus or service bus, where you have event routing and integration. If you are using service bus or events bus for integration, you connect. Then if you are using IBM BPM, workflow engine, orchestration and process automation, you have the connection there. And then this is also, your agentic system is also connected if you are deploying to hybrid cloud deployment. So you can deploy on-prem, private cloud, or public cloud, okay? And then the output of the agent is also bi-directional, okay? Feeding your regulatory APIs, connected to your regulatory APIs, connected to legal research platform, connected to data providers or visualization or KPI database, and connected to external connector like Power BI for visualization or other application, or wherever you want to use the outcome of whatever is coming from the system or the output of your agentic workflow. And all this, when implemented, enables legal legacy compatibility. That is, you are building a system that is compatible with your legacy application, which preserve investment and minimize risk, so that the money you've invested in the legacy application will not be wasted. Thereby, you will be improving the system and getting value. Then we have reliable connectivity, secure, resilient, and observable integration. That is what we have. You have workflow participation. So where agent participate in human and system workflows at the same time. And then you'll be having enterprise-ready integration. So when you have take care of this legacy application, sort out the and build the anti-corruption layer, where the agent connects through to the system. You have your event bus for routing and integration. You have your workflow engine for orchestration and process automation. You have your cloud ready, your hybrid platform, whether private, public, or on-prem ready. And then you have your outputs or consumption, and you have your service mesh for traffic management and everything. So what you are building indirectly or directly is enterprise-ready integration, enterprise-ready multi-agent system that will perform, and generate value to the enterprise. So you are building a scalable, governed, and enterprise multi-agent system is what you'll be having. Okay. And in summary, what is everything that we've discussed in chapter 9 all through. So we've looked at do not break existing system. So when you are designing multi-agent system, do not break existing system. Do not override the existing system. Rather, integrate with them to get your historical data from them and use it to, also augment your information that the agents are generating. 2, translate before agent reason. This is where you pass through anti-corruption layer by using data pipeline. So translate. Do not use coded information from the legacy platforms into your agent. Agent may not understand this. Make sure there is translation. All code must be properly translated to agent readable and human readable formats before usage. And then the next thing you do is you join existing workflow. So make sure you join agent with existing workflow. Do not override existing workflow. Join agent with the workflow to improve and to augment the workflow. So this is what agentic platform are for, and this is how you can integrate them into enterprise legacy application. So thank you for listening, guys. Hope you have gained something and also get a book to read more and understand more and see how this architecture are designed in practice. All right, please like and subscribe to our channel so you can get more information from us whenever we drop a video on things like this. And guys, my next book is titled Kadaba, Cognitive Architecture Design for Multi-Agent System. For enterprise multi-agent system, Kadaba is the name, and it's coming out is another book which is using building on top of the knowledge that we have on multi-agent system, and you are going to like it. Okay, so please go to our website remaAIsolutions.tech and drop your email to get a newsletter also, or read through our research platform where we post research and architecture information and what we are doing for company there. And then if you have a business for us, we'll be happy to connect with you. So please send us your contact information and then we'll get back to you accordingly. So as we deliver the best architecture using the first principle and applied mathematics, reasoning and thinking. Okay, and we work and we do our best to deliver the best and to improve the performance of your system and automate everything we have and delivering value at enterprise scale. So we build agentic AI, we build data engineering platform, we build audit dashboard and visualization, we implement MLOps, data ops, cloud computing, deployment on cloud, Kubernetes, Azure Container Apps, Azure App Services, Azure Function, Azure Synapse for data warehousing, Fabric. We also implement Fabric and so on and so forth. Please connect with us and drop us your information. We'll be happy to connect with you and to be of service to you. Thank you for listening, everyone.